All right, good morning. The purpose of this briefing is to report on the performance and capabilities of our new AI defense system, AEGIS Paladin. What if you could build a fortress around your AI that was so fast, so efficient, that no one would even know it was there? Well, that's what we've been working on. And we've just hit some milestones that are, frankly, going to set a new standard for enterprise security. So let's just get straight to the headline achievement, the number you see on screen. Less than 10 milliseconds. And to be perfectly clear, that's not the time for one check. That is the total judgment time for a single request to pass through all 6 layers of the Paladin defense system. It's security that literally operates faster than the blink of an eye. So the obvious question is, how is that even possible? Well, that's what we're going to break down in this briefing. Here's the plan. We'll start with why that sub-10 millisecond benchmark is such a game changer. Then we'll peel back all 6 layers of the Paladin architecture to see exactly how it works. We'll look at the 18 specific attack patterns it's built to stop, the next-gen algorithms that give it its intelligence, and of course, the secret sauce that makes it all run so incredibly fast. Finally, we'll talk about what this means for our security posture moving forward. Okay, first step, that sub-10 ms judgment time. Look, this isn't just about speed for speed's sake. What we're talking about here is a new benchmark, a new gold standard in what real-time AI security can and should be. And here is the most crucial takeaway. We're talking about a comprehensive, multi-layered defense-in-depth system that adds no perceptible lag for the end user. This isn't some theoretical number we hit in the lab once. This is the consistent operational speed of the entire defense pipeline. It means we can deploy this level of security across every single AI application in the enterprise without that dreaded performance trade-off. So how did we pull this off? The secret is really in the architecture. Paladin's strength comes from its sequential, defense-in-depth approach. We aren't just relying on one big wall or a single checkpoint. An attack has to successfully trick 6 distinct, specialized layers, one after the other, to have any chance of getting through. And here's a quick look at that pipeline. It all kicks off at layer 0, the trust boundary, which is basically validating the input itself, looking for tricky things like Unicode manipulation. Then it moves to layer 1, intent verification. This is our front line for catching jailbreaks and prompt injections. Next up, layer 2, RAGguard, is purpose-built to protect our retrieval augmented generation systems. From there, layer 3 uses machine learning for a much deeper semantic classification of potentially harmful content. And finally, layers 4 and 5 provide system-level protection, a circuit breaker to handle traffic anomalies, and a long-term behavioral analysis engine to spot suspicious patterns over time. This layered structure allows the system to be incredibly precise. So let's zoom in on layer 1, that intent verification layer, where we now have specific targeted coverage against 18 distinct categories of jailbreak and manipulation techniques. And this table really shows you the sheer breadth of that coverage. You can see this isn't some generic keyword filter. The system is specifically identifying and classifying attacks, from the common stuff like roleplay exploits all the way to highly critical threats like instruction overrides and even very specific Korean language prompt injections. And you'll notice each one has its own severity rating, which allows for much smarter, more context-aware responses from the system. But what's really exciting is how we're doing this. We've moved way beyond simple pattern matching and regex rules. The engine's effectiveness really comes from some cutting-edge, academically grounded algorithms that perform conceptual analysis. The first key algorithm is called GuardNet. The best way to think of it is as a system that truly understands context. It builds this hierarchical graph of the entire input, and it analyzes the relationships between individual words, then sentences, and then the prompt as a whole. This is what allows it to spot those really sophisticated threats that simple keyword matching would completely miss. The second algorithm, JB Shield, is a huge breakthrough for accuracy. It's based on a concept called the linear representation hypothesis. Now, in simple terms, this means it can tell the difference between a user who is just discussing a harmful topic versus a user who is actively trying to jailbreak the model to produce harmful content. It separates the toxic concept from the jailbreak technique, which, as you can imagine, dramatically reduces our false positives. So, to put it plainly, let's compare. Conventional methods, they're brittle. They rely on static lists of bad words, and they break the second an attacker gets a little creative with their phrasing. GuardNet and JB Shield, on the other hand, they're analyzing intent and structure. This makes them incredibly robust against new, novel, and even obfuscated zero-day attacks. Now, I know what you're thinking. This all sounds great, but it also sounds computationally expensive.
And that, of course, leads to the classic security question. How do you run all this complex analysis without grinding performance to a halt? Let's get into how we solved that security versus performance trade-off.
Right. This is the central engineering challenge we had to solve. How is it possible to run a 6-layer defense pipeline with advanced graph analysis and machine learning models in less time than it takes for a user to even notice? Well, the answer comes in 2 parts. The first is a really clever framework we developed called Sabre. It's built on a simple premise. The vast majority of queries are perfectly safe. So why make them run the full, expensive pipeline? Sabre acts as a high-speed pre-check. It scans for known high-risk patterns in less than half a millisecond. Think of it as an express lane for safe traffic, ensuring that our heavy analytical power is only used when it's actually needed. And the second part is our highly optimized machine learning engine. Now, for any query that Sabre flags for a closer look, this engine kicks in. It's running a specialized MD-BERTA model that performs multi-label classification across 7 categories of harmful content. But here, and this is the absolute key, is the strict, hard timeout. The entire machine learning process is guaranteed to complete in under 5 milliseconds. No exceptions. If it doesn't, there's a fallback. This design is our performance guarantee. It prevents any single complex request from creating a bottleneck in the system. So to conclude this briefing, what AEGIS Paladin represents is a new standard for AI security. It is proof that it's no longer a choice between comprehensive, deep detection and real-time performance. We now have both. And this really gets to the core philosophy behind this whole project. As one of the lead engineers on the team put it, the goal was never just to build impressive technology. The success of this system won't be measured by its tech specs, but by the number of accidents that simply don't happen. And that leaves us with a strategic question to consider. Now that we know that real-time, comprehensive AI defense isn't just a theoretical goal, but an operational reality, how does this change the game for us? How does this new capability shift our risk tolerance and change the way we think about deploying AI across the entire enterprise? It's a new security paradigm, and it opens up a lot of possibilities.